everyone, and welcome back to Atomic Structure with Miss Burkers. Today we're going to be going over lesson 13 in the booklet, which is compounds. Before we get started, I want you to make sure that you have your paper ready for you, along with any equipment that you may need. So a black or blue pen, as well as a feedback color pen, to make sure that you are able to make any corrections you need as we go through the video. So now that you have everything we need, let's get started. As is always the first part of the lesson, we're going to start with the knowledge check. So there are 3 questions here. Pause and finish them now if you need to. And then there are 5 more on the following page. So pause the video, give all the questions a try, and we'll go over the answers in a minute. So we'll go over the answers now. I would like you in your books, wherever you've written down the answers, to now switch to your feedback color and make the corrections that you need to make sure you have all the right answers in your booklet. So starting with question 1 here, the 3 subatomic particles that you need to know are the electron, the proton, and the neutron. The subatomic particles we find in the nucleus are the protons and the neutrons. Remember that these also give you the most of the mass in an atom. The subatomic particles found in the energy levels are the ones we don't find in the nucleus, so these are the electrons. So now we're going to go over to the next page and continue on. If you haven't had a chance to answer these now, pause the video and give them a go now. The overall charge of an atom is neutral. This is different from an ion when we've gained or lost electrons. The relationship between periods and energy levels, you should know that the period number is the same as the number of energy levels. Is equal to or the same as the number of energy levels. Remember that energy levels may also be called shells. The relationships between groups and outer electrons, that the group number is the same as the number of valence electrons or electrons in the outer shell. How to calculate atomic mass, so you add the number of protons plus the number of neutrons. Gives you the atomic mass of an atom. And the atomic number is equal to the number of protons. Remember that the atomic number is the smaller number when you look on a periodic table. So today we're going to look into compounds and what exactly a compound is. So you should have covered this briefly in your lower levels, but we'll have a quick reminder and then we'll get into it. So a compound is formed from elements by chemical reactions. So they're made by a chemical reaction. They contain 2 or more elements chemically combined. So for example, water is a common thing that everyone knows about and has a good idea of what it is. It's not a pure element. Water is what we call H2O, which hopefully you remember means there's 1 oxygen atom and 2 hydrogen atoms bonded to it. So it is a compound. It has different properties from hydrogen and different properties from oxygen. So it has properties all on its own because of how they are bonded together. So something else you need to know is they are in fixed proportions. So there's always 2 hydrogens for every 1 oxygen, right? If, for example, you have H2O2, so you have 2 hydrogens for every 2 oxygens, you end up with a very different compound. You end up with hydrogen peroxide, which is different from water. So you do need to make sure that it is in that fixed proportions. and they can be represented by formulas using the symbols of the atoms. So this here is an example of a formula, right? Chemical reactions can be represented by word equations or equations using symbols and formulas. So for example, one way you can make water is by reacting hydrogen and oxygen together. So we know in real life, hydrogen exists as H2, and we can react that with oxygen, which is also H2, which gives us H2O. Now we'll get more into balancing in a minute, but you'll see here there's 2 hydrogen atoms, but only 1 oxygen atom, whereas we can't have half of an oxygen molecule. So we actually need to add a 2 here and a 2 there to make sure it's balanced. But as I said, we'll get more into that later on. We can also represent the same equation by saying hydrogen plus oxygen reacts to form water. So there's different ways of doing that. What I'd like to do now is pause the video and we'll have a go watch this fused school video. So you can either click on the link or you can just put into YouTube element mixture compound fused school and it will pop up. Hopefully you have more of a better idea now of the difference between an element, a mixture, and a compound. So now we're going to go into naming of the compounds and how do we give these all different names. So the name depends on the elements that are being combined. So it usually stems from the names of it, though sometimes it is a completely different name. So when we have a metal ion and a non-metal ion involved, so a metal and a non-metal, which we call ionic bonding, we use a combination of their names to name the compound. The metal is first, the non-metal has its name changed a little bit to show that it is an ion, and it always comes second. All right, so for example, if we react sodium, which is Na, and chlorine, which is Cl, when they combine, sodium, which has 1 extra electron in its outer shell, which is trying to get rid of, will give it to chlorine. So sodium will form a positive 1 ion, and chlorine will form a negative 1 ion. So we draw square brackets to represent the ions. And so now we no longer have sodium and chlorine, it's now as a compound. They've joined together. So we have what we call sodium. So we use the name of the metal, so sodium. And then we change the ending of chlorine to "ide", and so we call it sodium chloride. So these videos here, so this first one is just to remind you how an ionic bond works, which is from a couple of lessons ago if you don't remember. If you feel good about your ionic bonds, you can skip that one. And then I just like you to watch these 2 videos here about how to name these ionic compounds. And then we'll come back and we'll do some examples of them. All right, so hopefully now you have a better idea of how to name these ionic compounds. So we're going to do some practice with them. So as I said, we're starting with ionic compounds, which, think back for a second, what type of elements come into an ionic bond? Yes, it is metals and non-metals. So a metal plus a non-metal will give you an ionic compound. So as I said before, and as you saw in the video, we always start with the positive ion first. So most metals are all positive ions, so if there's a metal, sometimes we can have non-metal positive ions. So for example, ammonium is one, and there are some other ones, and you'll learn about those as we go on. All right, and then we do the negative ion. So again, if there's a non-metal, that will be a negative ion, and we change the ending to "ide". So chlorine will turn into chloride, oxygen to oxide, sulfur to sulfide. Sometimes again, we have a group of metal or a group of nonmetals that forms an ion. So we call that a polyatomic ion. Poly meaning many, atomic atoms. So for example, calcium carbonate will turn into an ion copper sulfate is again, or carbonate is an ion. Sulfate is an ion. So we use the ending 8 if it's that polyatomic. You will see mostly the "-ide", but you might see a couple 8s as well. So looking at this task here, if we have our positive, our magnesium is a metal, our negative ion is oxygen. So we start by saying the positive ion first. So we'll say magnesium. And then we write the negative ion, but we can't just write oxygen. We have to change the ending to "-ide", so it's ox-ide. So that's what we're doing for that one. If you look at the next one, they've given us the name of the compound, lithium oxide, but we need to write the names of the ions. So the positive ion will be the metal, which in this case is lithium. We know this because they've written lithium first. So we know that needs to be the positive ion. So we just write lithium. It's oxide, which we know there's no element named oxide, but we've changed that ending and we know it's oxygen. So now what I'd like you to do is pause the video and give all the rest of these a try. Copy this table into your book if you need to, and then just write out all the rest of them and see how many of them you can get. We'll go over the answers in a minute once you've given it a go. All right, so now that you've had a chance to give them all a go, you filled them all out, we'll go over all the answers. So for this next one, the positive ion is sodium. We know that because sodium comes first, the second bromide, but we know that ending has changed. I've also look in the formula and see that Br, which I know is bromine. So I know that's my negative ion. Potassium, it doesn't say which one is, because I can't look at the compound name, but I can look at the compound formula and see the Cl, so I know that's chlorine. So when I write the compound name, I start with the positive ion, start with the metal. So I write potassium, and then chlorine, but I've changed the ending to "-ide", chloride. All right, the next one, I look at my formula, Al, I know is aluminum. Cl, I know is chlorine. All right, and then I have aluminum. I don't need to change and chlorine, I know I have to change to chloride. So the next one, aluminum, O, I know is oxygen, which turns into aluminum. And oxygen, I can't just write oxygen, I need to write oxide. So Na, hopefully you'll remember, is sodium and sulfur. So I know I start with sodium. I don't need to change that, but the salt, I can't just write sulfur, I know I have to change the ending to "-ide", and so it turns into sulfide. All right, at this point, if you struggled with it before, but now have a better idea, pause the video again, try the rest of it, and then come back. Otherwise, if you have it all done already, then we'll go through and go through the rest of the answers. So boron, I don't need to change the name because it's the positive. Sulfur, I need to change the ending to "-ide", so it's boron sulfide. Li, I know is lithium. Br, I know is bromine. If you needed a periodic table to do this, that's no problem whatsoever. That is something that you will have on an exam. You'll have access to a periodic table, so don't worry about that at all. And then the name will be lithium bromide, because we've had to, again, change that ending to "-ide". K, I know is potassium. This is a tricky one. I know a lot of people struggle with that. F is fluorine. Potassium fluoride. All right, so we just finished the last two up there. So I just want you to look, make sure you have them. So Mg, magnesium, and nitrogen, change that ending to ide. So that's nitride. That might have been a bit tricky for you. And then beryllium and oxygen for the last one. Now that we've done the single atom ions, we're going to try some of the polyatomic compounds. Hopefully you remember that the word polyatomic means that there is more than one atom within the ion. So what I'd actually like you to do here for the negative ions, it's carbon and oxygen. CO3 isn't carbon and oxygen, it is a carbonate ion. And nitrogen and oxygen isn't a nitrogen and oxygen, it forms a nitrate ion. So knowing that, I'd like you to give a guess as to what the compound name might be if you mixed a calcium ion and a carbonate ion. If you've said to yourself, isn't that calcium carbonate? You are correct. It is calcium carbonate. So the next one, again, very simple, ammonia nitrate. And for this last one, the positive ion would be your iron, and your negative ion is your nitrate. So straightforward enough, just remember that sometimes you have a whole ion, such as NO3 is a whole ion on its own. So when naming, so that is the ionic bonds, when we name ionic compounds. Sometimes we have covalent bonds. So when we have only nonmetals, that is a covalent bond. These we have to name a little bit differently. So sometimes the name can be the combination of the elements, like we've seen with ionic bonds. However, sometimes it can be completely unrelated to individual elements. I want you to think about now that you have a pretty good understanding of naming ionic compounds, so that's a compound with an ionic bond within it, we're going to look at naming covalent compounds, or if it has only nonmetals. So it has a covalent bond, because we know that nonmetals form covalent bonds because they have to share the electrons. So sometimes it can be a combination of the elements, as we saw in ionic bonds, and sometimes it's completely unrelated to the individual elements. For example, I want you to think of the covalent compound with 2 hydrogen atoms and a single oxygen atom. You know that this is the compound of water. It has nothing to do with the elements within it, we just call it water. Whereas if you think of CO2, another very common compound that we discussed that is covalent, we know we call this one C for carbon dioxide because there's 2 oxygens. So this is the difference in using the elements of the compounds or just having an individual name. Another very common name is CH4, which is methane. It's another very common compound that we talk about that has a name other than something to do with the elements. So one thing you need to know are the basic prefixes that indicate the quantity of each element used. So a prefix is anything we put before a word. For example, here where we talked about the dioxide, the quantity we know is the scientific term for number. Right? So we if you look at the bottom of the page here, we do have our list of prefixes. So if there's 1, we use mono, 2 is di, 3 is tri, 4 tetra, penta, hexa, hepta, octa, nona, and deca. You'll notice that it goes in with the shapes. For example, for maths class, an octagon is a shape with 8 sides. A hexagon is a shape with 6 sides. So that should help you remember the ones that it is. Something we don't talk about in maths is a mono-sided shape or a di-sided shape. Right? We talk about a triangle, and the other one is a tetra. So these are the 3 I want you to really focus on and remember that 1 is mono, 2 is di, and 4 is tetra. So when we start with naming, you first look to see what the first element is. If it starts with a hydrogen, for example, HCl or HBr, all right, then it's hydrogen chloride, hydrogen bromide. So we use ionic rules for this. Because remember, this will be easier to remember if you think about the periodic table and the fact that hydrogen can sometimes act like a metal. So we use the ionic rules. Okay. Occasionally, when we dissolve these in water, they form the acid, such as HCl, hydrochloric acid, or HBr, hydrobromic acid. But that's only when it's dissolved in water. So that's not one you need to worry about. Another common one that starts with H is water, or H2O. All right, that is one that just is water. It's not an acid. It starts with H. It's the one, water is an exception for a lot of rules. This is just another one. So if the compound starts with a different nonmetal to hydrogen, so if it starts with any other nonmetal, such as our CO2 here, then we use the prefix in front of the element. So for the first one, we have 1 carbon, so we don't have to add a prefix. For the oxygen, we do have 2 of them, so we have to add the prefix for the number. If we only had 1 oxygen, we would have to call it carbon monoxide. Using some of those rules, we're going to look at some compounds and fit them to the rules. So for the task 1 here, what I need you to do is to use your periodic table and try to name these compounds as well as saying the second element. You'll notice that this last one isn't just a single element, but is a polyatomic. So you might need to Google it, but I'd like you to find the name of that polyatomic, and the rest you can just use your periodic table to find the name of the element. Then I want you to try writing the compound name. For example, we will give a go to HCl here. So as you remember from the previous page, when it starts with a hydrogen, you do hydrogen chloride. So you change the ending to "ide." So hydrogen chloride. This one would be hydrogen, and S is sulfur, so hydrogen sulfide. So fill them all in and then check the answers in a minute. Here are the correct answers for task 1. So you see HCl, hydrogen chloride, HBr, hydrogen bromide, so on and so forth. The NO3 is called the nitrate ion, which turns into the nitric acid. So pause the video, get those answers in, and we'll move on to task 2. So now we're going to look at some covalent bonds, ones that are not with hydrogen. So you'll see here, the first one has been done for you. So I would like you to cross out ions because we're not dealing with ions at this point. So it's just the first atom and the second atom, just to help you see which one it is, and then the compound. So you'll see for here, dinitrogen tetraoxide, there are 2 nitrogen atoms and 4 oxygen atoms. So that's why we have the dinitrogen tetraoxide. Remember that the first one, if there's 1, no prefix. 2 or more, you need the prefix. For the second atom, you always need a prefix. So for example, let's have a look at N2O. So N stands for nitrogen. O is oxygen. We have 2 nitrogens, so we need to say dinitrogen. But we only have 1 oxygen. But because it's the second atom, we always need that prefix. So we need to say monoxide. You notice that if we start with a vowel, instead of saying monoxide, we just say monoxide. The same is for here, we cut out the A in tetra, we don't say tetraoxide, tetroxide. So we cut off that final vowel to help it flow better with oxygen. Right, so there are several here. I'd like you to just go through, give them a go. So pause the video, give them a go, and we'll go through the answers in a minute. Here are the answers. Hopefully you noticed that carbon monoxide was there twice, so I haven't written it in twice and you don't need to either. Pause the video, correct any mistakes that you have, and then we'll move on from there. So when we're looking at chemical reactions to form these compounds, we often put them into word equations. So we now know how to name any of these compounds, so now it's really easy to put them into the word equations. So we can say magnesium and chlorine react to make magnesium chloride. Lithium and oxygen react to form lithium oxide. We always show it with an arrow. So we have the reactants to the left of the arrow. So remember that reactants are the before of a reaction. And the products are the after, or what is made in the reaction, and they are to the left of the arrow. So these often come in handy, especially when we're talking about it, but they don't say anything about how much magnesium or how much chlorine we're using, or how much magnesium chloride we end up with. So they show us nothing about the ratio of each reactant. So more often than not, in chemistry, you see the symbol equations. So for example, for magnesium and chlorine, giving us magnesium chloride, we use the symbols to show us how much magnesium and chlorine we have. So in magnesium chloride, because magnesium is a +2 ion, whereas chlorine is a -1, in order to balance those charges, we need 2 chlorines and 1 magnesium. So we end up with MgCl2. So we have the same numbers. However, every reaction needs to follow the law of conservation of mass, which states that mass in a reaction is neither created or destroyed. This comes in important because if we look at, for example, lithium and oxygen making lithium oxide, oxygen we know exists as O2. We will never find in nature oxygen existing just as a single atom ready to react. It'll always be as a molecule of 2 oxygen atoms. However, in a single lithium oxide molecule, there is 1 molecule of oxygen and 2 atoms, 1 atom of oxygen and 2 atoms of lithium. So here we have 2 and we end up with only one pink dot. We need to end up with that second pink dot. We need to end up with a second atom of oxygen, because that oxygen can't just disappear anywhere. So we need to have 2, which is what this 2 represents, molecules of lithium oxide. Lithium exists as a metal, so it's a single atom that it is, but it can't, but so here you need to count how many lithium atoms we've used. We used 1, 2, 3, and 4. So we need to add a 4 in front of the lithium to completely balance that equation. So we started with 1, 2, 3, 4 atoms of lithium, 1 molecule of oxygen. So we don't need to add that 1, the same as in maths when you're multiplying. And then we ended up with 2 molecules of lithium oxide. So, as I just showed there with the highlighting, that's what this turns into. So I'd like you, without looking above, to try to write out that equation again and balance it without looking at the example above. So hopefully you have that you need 2 lithium oxide molecules, and so you need 4 lithium atoms. So that would be how we balance an equation. Remember the law of conservation of mass. Mass is neither created nor destroyed. So what we have before needs to equal what we have after. So here's adding on to that, going with that. This is something that can be very confusing. So here are two videos that you need to watch in order to fully understand balancing equations. You may need to watch them more than once, and that is completely all right. This is something that is challenging. It's something you need to practice, and it gets easier with practice. So watch these videos, pause them, do the examples that they show, and do your best to try to understand it. If you still have questions after that, email your teachers. Once you've watched that video, here's a sheet where we're going to do some practice of balancing equations. The more you practice it, the easier it does get. So, one way to make it easier to do is to actually grab your colored pens and draw it out as you need to. So H2, we have 1 molecule of H2, 1 molecule of Cl2, and then we have 1 Cl and 1 H, or 1 chlorine and 1 hydrogen. So I need 2 hydrogens, so I need a second hydrogen, and it needs to be attached to a chlorine. So I see now, so I have 2 hydrogens on the right of the arrow and 2 hydrogens on the left of the arrow, so hydrogen is balanced. So I can just add a little tick above hydrogen. Chlorine, I have 2 on this side, I have 2 atoms on this side, so that's balanced. And so everything in this is balanced, so I don't need to add any numbers. Looking at the next one. So zinc, 1 zinc. Oxygen is O2, 1, 2. Zinc oxide, zinc oxide. Okay, my zinc is balanced, that's fine. Then I look at my oxygen. I have 2 here, 1 here. Oh, it looks like I need to add another oxygen. And that oxygen has to come with the zinc. So now I have 2 oxygens, so now my oxygen is fine. But wait, I have 1 zinc and 2 zincs. So I need to add a 2 in front of it. I can't add a small 2. You cannot alter the subscript. You need to add more to it. So I need to add a second zinc. All right, now zinc is all right. Trying this as you go down. It takes practice. I know there's a lot there, but as you do more and more of it, it will get easier. Here are the answers to those balanced equations. I want you to check them with what you have and make sure you have the correct answers. The one thing I want to correct before you do that is this last one you probably really struggled with, because this should not be SO2, it should be SO4. In which case you just need 2 hydrochloric acids and 2 potassium chlorides. So check your answers, and we'll leave it there for today. If you have struggled with the balancing, that's completely natural. There's lots of extra online practice, so just Google balancing chemical equations practice and you'll find lots of other examples. If you're struggling to find it, email your teacher and they will be able to help you find some more resources from that. If you struggled with anything in the lesson or if you have any questions, make sure you email your teacher and they can help you in whatever way they can. And otherwise, we'll see you next lesson.